Welcome to the video on indefinite integrals and substitution. So if you have an indefinite integral of the form, the integral of f of ax plus b dx, that'll equal 1 over a times your integral of f of x, where x equals ax plus b. So for example, if you had the integral of cosine of 3x plus 2, it would be 1 over 3 times your integral of cosine, which is sine, and then you'd have your 3x plus 2 on the inside. And then you can't forget your plus c. So here are a bunch of functions where you need to know these integrals. So if we have x to the n, where n is an element of the rational numbers, the integral of that is 1 over n plus 1 times x to the n plus 1 plus c. If you have the integral of sine of x, that'll equal negative cosine of x plus c. The integral of cosine of x would be sine of x plus c. The integral of e to the x is e to the x plus c. And your integral of 1 over x is the natural log of the absolute value of x plus c. So these are all integrals to memorize. So first we have integration by inspection. Integration by inspection is the reverse of the chain rule. So essentially what you would do is rearrange the integral to a form where the integral becomes relatively obvious. So here are two quick examples. So for this one, we have the integral of 3x squared plus 5. We know the derivative of x cubed is 3x squared. So our integral of 3x squared is going to be x cubed. And then the integral of 5 is 5x because you just add the x. And then you can't forget your plus c. So that would be the integral of that. Then our integral of e to the negative 3x minus x dx would be negative 1/3 e to the negative 3x minus 1/2 x squared. When we have a number times x in our exponent of e to the x, you just do 1 divided by that for your integral. So this is the integral of that, and then you can't forget your plus c. Finally, we have integration by substitution. When the integral can be rewritten like the following integral here, then the inside function, g of x, can be substituted for u so that it's possible to take the integral by hand. So if you have the integral of some number times the derivative of g of x times f of g of x dx, that will equal k, your constant, times the integral of f of u du, where u is equal to g of x. So for example, if we had the integral of 4x times the cosine of x squared dx, we take our function inside of it, our x squared, and find the derivative of that. So x squared is going to equal u. So the derivative would be 2x dx equals du. So 2x dx equals du, and x squared equals u. So this will be u, and then if we have 2x, so we pull a 2 out, and our dx, so this and this equals du. So if we pull the 2 out front, we have 2 times the integral of the cosine of x squared times 2x dx. So then that's u, and this is du. So we have 2 times the integral of the cosine of u du, which equals 2 times the sine of u plus c. So now we want to substitute back in our u. So then this is going to equal 2 times the sine of x squared plus c. So that's how you would find your integral using substitution. So here we have our first IB practice question where no calculator is allowed. It says solve the following integrals. So we're going to use substitution for most of these. So here our denominator is 1 degree greater than our numerator, so we'll try using that for u. So u equals 3x cubed minus 2. So if we take the derivative, du equals 9x squared dx. So we have an x squared. To turn it into 9x squared, we'd multiply it by 9 and then put 1/9 on the outside. So that means that 1/9 times the integral of 1 over u du equals 1/9 times the natural log of the absolute value of u plus c. So then we can substitute back our 3x cubed minus 2 for u. So our solution would be 1/9 times the natural log of the absolute value of 3x cubed minus 2 plus c. For part b, it's the integral of x squared times e to the x cubed dx. So we'll use our exponent here as u. So u equals x cubed, du equals 3x squared dx. We have an x squared, so we'll multiply it by 3 and put 1/3 on the outside. So we have 1/3 times the integral of e to the u du, which equals 1/3 e to the u plus c. And then when we substitute x cubed back in, we get 1/3 e to the x cubed plus c. Finally, part c is the integral of cosine of x times sine cubed of x dx. So we need to get rid of either our sine or cosine. Otherwise, we need to use the inverse of our product rule, which would get really confusing. So we'll try using sine of x for u. So our cosine of x is du. So cosine of x dx equals du. So this turns into the integral of u cubed du, which equals 1/4 u to the 4th plus c. So we substitute our sine of x back in for u. So this equals 1/4 sine to the 4th of x plus c. Now we have our second IB practice question. It says find the exact values for the following integrals. So these integrals have lower and upper limits. So this first one will put u equals x squared. So du equals 2x. So we'll have the integral of e to the u du. But our limits of integration have now changed because these are for x and now we're using u. So you could go ahead and change your limits, or you could wait till the end when you substitute x back in to use your limits. So I'll do that with this first one. So this equals e to the u plus c. So we're going to substitute x back in. So we have e to the x squared. And now we can do evaluated from 1 to 3, which equals e to the 3 squared minus e to the 1 squared. So that's e to the 9th minus e. So that would be your solution. For the second one, we have the integral from 0 to 2 of 3x minus 5 to the 4th dx. So u will equal 3x minus 5. Du is 3 dx. So we need to put a 3 in here. So we'll put a 1/3 out front. So we have 1/3 times the integral of u to the 4th du. So if we wanted to change our limits of integration, u equals 3 times x minus 5. So we could find u when x is 0 by plugging in 0 for x. So this would equal -5. So our lower limit would now be -5. And our upper limit would be when x is 2. So that would be 6 minus 5, which equals 1. So we'd have the integral from -5 to 1. So this will equal 1/3 times 1/5 u to the 5th evaluated from -5 to 1. So this equals 1/15 u to the 5th from -5 to 1. So if we evaluate this, we get 1/15 times u, which we're substituting in 1 to the 5th, minus 1/15 times -5 to the 5th. So this equals 1/15 minus 1/15 times negative 3,125. So this is 1/15 plus 3,125 over 15, which equals 3,126 over 15. So if we wanted to go ahead and substitute back in our 3x minus 5 for u and not change the limits of integration, we could go back to this 1/15 u to the 5th plus c, and then we'll substitute in our 3x minus 5 for u. So 1/15 times 3x minus 5 to the 5th, evaluated from 0 to 2. So this would be 1/15 times 3 times 2 minus 5 to the 5th minus 1/15 times 3 times 0 minus 5 to the 5th. So that equals 1/15 times 6 minus 5, which is 1, to the 5th, minus 1/15 times negative 5 to the 5th. So if you look, this is the exact same as this step right here, so it'll come out to the same answer. So finally, we have part C, which is the integral from 0 to pi of cosine of x times sine squared of x dx. So our u will be sine of x, so du equals cosine of x dx. So we'll have the integral of u squared du, which equals 1/3 u cubed plus c. Then we can go ahead and plug in our sine of x for u. So we have 1/3 sine cubed of x evaluated from 0 to pi. So this would be 1/3 sine cubed of pi minus 1/3 sine cubed of 0. The sine of pi is 0, so this would be 0 minus the sine of 0 is also 0, so it's 0 minus 0, so it just equals 0. So that's how you find the answers to these questions. So in summary, our integral of f of ax plus b dx equals 1 over a times the integral of f of x, where x is ax plus b. Integration by inspection is the reverse of the chain rule. The integral is rearranged to a form where the integral becomes relatively obvious. And when the integral can be rewritten like the following integral, then the inside function g of x can be substituted for u so that it is possible to take the integral by hand. So this here is substitution. In addition to all of that, we need to memorize these integrals because they'll be important to know for your test. That's all for this video. Thank you for watching.